Welcome to the solution to the Regents Physics statics problem set, question number 1. Let's start by reading the question here. We have a river flows toward the east. Because of your knowledge of physics, you had your boat 53 degrees west of north and end up with a velocity 6 meters per second due north relative to the shore. Using a rough sketch and calculations, find the velocity of the current of the river and your speed relative to the water. Well, we're going to label some things here that we have. In A, the velocity of the current of the river, we're going to call that VR, velocity of the river. And your speed relative to the water, we're going to call that VB, the velocity of the boat. What we are told here is that you had your boat 53 degrees west of north and end up with a velocity of 6 meters per second. We'll just label that as V, and we'll label that with a subscript S relative to the shore. Down here, we've given ourselves a coordinate system, and there is compass rose in this problem. So we're going to go ahead and label our north, south, east, and west. And our east-west axis is going to be parallel to the shore. Okay? All right, let's reread this and see if we can get a sketch going here, because there's a lot of what potentially could be confusion in this question. A river flows toward the east. So we're going to take a vector and put it, starting at the origin, on the east axis. Move that up so it's on the axis. Okay? This is the velocity of the river, VR, as we mentioned earlier. All right, let's continue to read. Because of your knowledge of physics, you head your boat 53 degrees west of north. This is a rough sketch, so we're just going to take 53 degrees west of north and end up with a velocity 6 meters per second due north relative to the shore. Okay, so this vector we just labeled on our diagram is VB. That's the velocity of our boat. And what we end up doing here, if you can imagine, if you point your boat in a northwesterly direction, in this case 53 degrees west of north, but your current of your river is going east, that is how you could end up going straight north at 6 meters per second. So our velocity relative to the shore, that is what a person standing on the shore would see us doing, is going straight across this river at 6 meters per second. Okay? All right. Our job is to find VR and VB. Let's label the angle also. 53 degrees west of north would be this angle right here. Okay? To solve this problem, we do what's called the parallelogram method. The parallelogram method is a method you use when you have concurrent vectors acting on an object at the same time. So to draw the parallelogram, we would need a vector that is the same length as our velocity of our river vector attached to the end of our boat, and we would need same magnitude, same direction. Now we would need a velocity of a boat vector, and these look to be a little long, but it's okay, it gets the point across. Attach the end of our velocity of river vector to create the parallelogram. The parallelogram is created by vectors that are same magnitude and direction. You notice that by doing this, we form, because the velocity relative to the shore and the velocity of the river are perpendicular to each other, we end up forming two right triangles with our parallelogram. This is what we want so that we can use trig functions and trigonometry to solve for the answers. All right, so let's get to it. A wants us to solve for the velocity of the river, VR, the current of the river. What trig function relates VR, VS, and the 53 degrees? Well, this side of our parallelogram is the same length and magnitude as VR. It is opposite the 53 degrees. The velocity relative to the shore is adjacent to the 53 degrees. By that analysis, we would use the tangent function to do it. So the tan of 53 degrees would be opposite VR over adjacent, which is the 6 meters per second relative to the shore. Solving for VR, multiply both sides by 6, so it would be 6 tan of 53 degrees. When we calculate, go ahead and pause if you need time to do so, we would get a velocity of the river of 8 meters per second. Okay? B, your speed relative to the water. They're asking us here to find VB. VB is the hypotenuse of the right triangle. What trig function relates VB, the 53 degrees, and the VS value originally given in the problem? VB is the hypotenuse. VS is the side adjacent to the angle. Adjacent to hypotenuse would be the trig function cosine. So the cosine of 53 degrees would be adjacent 6 over hypotenuse, which is the velocity of our boat that we're looking for. Here we have to solve for VB, and VB then would be 6 divided by the cosine of 53 degrees. Remember, we talked about this. These two just switch. What you're really doing is multiplying both sides by VB and dividing both sides by cosine 53 degrees. Go ahead and calculate. Pause if you need a moment to do that. And check in your answer. We should get 10 meters per second. This should make sense to you, by the way, in hindsight, because 53 degrees is one of the angles in the 3, 4, 5 triangle. So the ratio of our sides is 3 to 4 to 5. Well, VS would have to be the 3 side, so the factor there is 2. 3 times 2 is 6. So 4 times 2 is 8, and 5 times 2 is 10. All right, that'll do it for number 1. More practice with solving these kinds of vector problems in class tomorrow.